नमस्कार। मैं एक बार आप सभी का इस इंटर्नशिप ट्रेनिंग प्रोग्राम में स्वागत करता हूं। आज हमारे बीच संदीप सर हैं जो मोबाइल 5G के ऊपर अपना सेशन डिलीवर करेंगे। और 5G से रिलेटेड जो भी क्वेरी है, क्वेश्चंस हैं, वो आप लोग पूछ सकते हैं। और सर का भी बहुत अच्छा एक्सपीरियंस है मोबाइल के फील्ड में। तो इनसे जो भी आपके मन में डाउट है, सवाल है, जो क्रिटिकल एस्पेक्ट में लगता है, क्रिटिकली तो पीपीटी सब वो सब मिल ही जाती हैं, रिकॉर्डिंग सेशन भी आपको मिल जाएंगी। कोई क्रॉस क्वेश्चन है, कल हमने जैसे संजय सर से पूछ बता रहे थे, एक दो क्वेश्चन आप लोगों ने डाउट था वो हम लोगों ने पूछा। तो ऐसे ही अगर आपके मन में किसी तरह का कोई सवाल या क्वेश्चन है तो डेफिनेटली आप पूछिए। आपका डाउट क्लियर करेंगे संदीप सर। और मैं संदीप सर का एक बार तहे दिल से स्वागत करता हूँ इस ट्रेनिंग प्रोग्राम में। तो आगे का डिलीवर के लिए मैं उनको यहाँ पे बुलाता हूँ। सर आपका स्वागत है। गुड मॉर्निंग टू ऑल।
Good morning, sir.
Good morning, sir.
गुड मॉर्निंग, गुड मॉर्निंग। Am I audible ना?
Yes, sir.
Okay. Today we will take lecture on the 5G network architecture and its key enabler technology. You can say key technology. What are the key technology which enables the 5G, right? So first we will discuss the 5G network architecture, then some key air interface technologies, how they incorporate in the different use cases in 5G, right? All of you know the previous generation, just 4G or 3G, 2G mobile network architecture. No. So first, how the evolution from 4G to 5G it will take place. I think all of you know the network architecture contains the three parts. First one is the user equipment. That user equipment connect with the radio access network. E node B is a part of radio access network. Then radio access network is connected with core network. The core network of 4G is known as EPC, Evolved Packet Core, right? This one, number one, that is the legacy network, that is the 4G network architecture, right? In a very small, you can say, component, na? Only EPC, E node B is written here and E is written here, right? And from this 4G to 5G, there is a transition phase, right? From if you any operator, suppose they Reliance Jio or any operator having their 4G network, na, so there is a transition phase when they are going to convert their 4G to 5G. The one transition phase is known as the standalone deployment. Non-standalone, this one is the pure 5G network, where there is a core network of 5G, okay, radio access network of 5G, and user equipment of 5G. This one is known as the standalone architecture, or you can say deployment option for any operator. How they deploy the equipment in their network. This one is the transit phase. Transit phase means they are having core network of 4G. Okay, if you can see here, na, all this legacy network is there. UE, E node B, and EPC. Only by adding a G node B, or we can say base station of 5G, we can deploy the 5G network with the single use cases that is known as the enhanced mobile broadband. That is clear here. This deployment or transit phase is known as non-standalone deployment. You might have heard sometimes NSA and SA. This one is the non-standalone. That means that is the transit phase from 4G to 5G. And this is the standalone 5G network architecture. Right? Just NSA and SA architecture, right? SA standalone means your all the equipments, all the parts of the architecture, that means the radio access network and core network are having the 5G equipment, right? But in the NSA, that is the transit phase of between 4G to 5G, that is the adding just the radio access network G node B in between the radio access network, in between user equipment and core network. Right, this point is clear. From operator of point of view, there is a transit phase from NSA from 4G to 5G, that is NSA, and full-fledged 5G, that is the standalone SA mode, right? These are the some 3GPP specified non-standalone deployment options. Option 3, option 3A, how they can deploy it actually, option 3X. All of these are the 3GPP specified. Option 7, option 7A, option 7X. Okay, the most popular deployment option is the option 3X, right? Where 4G 4 is there, that is EPC, and 4G base station, that is the E node B, and also the 5G base station are connected with core network of 4G. And this UE actually enabled with 4G as well as 5G data. Download with dual connectivity of 4G and 5G base. Right? Any confusion regarding non-standalone option and standalone option, deployment option? Okay.
Hello.
Hello.
Yes. What is G node B? That parallelly.
Node B is just the name of base station of 5G. Next generation node B.
Yes.
E node B is the base station of 4G. That is the E node B, evolved node B. Right. A 3G base station is known as the normally node B, only node B. And our GSM 2G base station is known as the BTS, base station transceiver. Right, sir? So different name of base station in different generation. Clear, sir?
Okay.
Thank you, sir. Now this one is the same. Architecture is written here. How the voice service flow and how the data service flow. This one is the architecture. This one is the mobile equipment. And after mobile equipment connected with the radio access network. Okay, radio access network of 2G, 3G, 4G, 5G are different, na? Different name of the base station. There is a generic base station is marked here. That UE is connected with the base station and base station is connected with the core network. And core network is further connected to with the internet, or you can say data network, external network, right? The voice service flow actually comes in 2G and 3G circuit switch call flow from UE, then it comes to core network and then comes to another mobile equipment. But your data service flow from UE to core network and then core network to your server, internet server, data server, right? So these are the flow of data, how they are flowing and where they are flowing. This is the general architecture of 4G and 5G network architecture. I will discuss what are the changes has been done in the 5G and why these changes had been done. Right. These are the general architecture 2G and 3G and 4G. You can see here, na? There are two nodes in the radio access network of 2G, 3G. In the 2G, there is a radio access network, there is a BTS and BSC. Two nodes are there. In 3G, there are two nodes in the radio access network, that is node B and RNC, radio network controller. This radio RNC handles a number of base stations, number of node B, maybe 100, maybe 150, maybe 50. It depends on the capacity of the RNC. That is the vendor specific. Totally it is the vendor specific. In the core network, you can see here there are two nodes for packet switching, SGSN and GGSN, and MSC and gateway MSC, one more MSC there. That is the part of circuit switch core network. Mobile switching center. That is the now in the 4G, there is no more circuit switching in the fourth generation network. You can see here only serving gateway and PDN gateway. If we compare from the 4G network, serving gateway can be analogous to SGS and PGW can be analogous to GGS. There is no MSC, VLR or gateway MSC, right? So 4G is a fully IP-based network, right? There is no circuit switch, packet switch network is there. And from two nodes in radio and access network, there are only one node in 4G. All the functionality of RNC and node B exists in the E node B only. So this types of architecture of 4G is known as the flat architecture. Right? The flat. Why flat? Because some of the hierarchy is removed. Some of the hierarchy is removed in the fourth generation. What are the need of removing the hierarchy? To reduce the latency. If we remove the some of the hierarchy level, that is the delay introduced by the processing of that node can be reduced, and by reducing that delay of processing delay, the overall latency can be improved. Right? Here in the radio access network, only one node, but in the core network, that is the EPC of 4G, they are basically for two nodes, serving gateway and PDN gateway for user data flow. MME is handling the control traffic only, right? For packet users data traffic flow from 4G to phone to user equipment, views13 or E node B to GGW and PGW. If you come on the 5G, only one node present in the core network also. There are hierarchy level reduced further in 5G. We will discuss in later slides, right? Because of to reduce the latency. In the 5G, peak latency is 1 millisecond, end-to-end peak latency. How we will achieve 1 millisecond? A number of things is there to architectural evolution, right? And some signaling evolution. We will discuss in the subsequent slide. Any confusion, sir, in this slide? Actually, this slide shows the overall picture of second generation, third generation, our legacy network architecture actually. So if you have any query regarding this architecture of legacy network, second generation, third generation, and fourth generation, then you can please ask any question if you have.
That MME, can you explain what's the full form?
MME means Mobility Management Entity. That is a node in the core network of 4G that handles only the control traffic. Control traffic means when the requirement of authentication, when there is a requirement of paging of channels, when there is a requirement of tracking area update, like in legacy network 2G, 3G, location area update is there. That is the control traffic handled by the MME only. There are two types of traffic, control traffic and user plane traffic. So, control plane traffic handled by MME and user plane traffic handled by serving gateway and PDN gateway. P means PDN, packet data network. GW means gateway.
Now it's clear. Thank you.
Okay. So 5G becomes the all cloud native architecture. Cloud native means your all the processing, storage, everything goes into the cloud, right? Here you can see and the SDN and FPO and so there are different types of cloud. We will discuss edge cloud, regional cloud, core cloud. Edge means near to the user, near to the base station. Regional cloud means at aggregation level. Core cloud means at a centralized level. So the cloud may be at different locations. Depending on the location, there are different names that is written here. Edge cloud and regional cloud and core cloud. They are located based on their location. They are server location, the name is different, right? Function are somehow same. Now comes here is the service-based network architecture of 5G, right? Service-based network architecture of 5G. In the left-hand side, you can see here the core network of 4G, right? And here, on the right-hand side, there is a core network of 5G. There are different elements actually in NES, UDM, PCF. These are the different functions. That functions is virtualized actually. These are not the physical entity. Here in the 4G or legacy network, all these nodes, HSS, MME, PCRS, actually in the previous slides, only 3 nodes are showing here, na? That in MME, serving gateway and PGW. But some more nodes are there, but main nodes are 3 nodes. Some database, HSS is the database where all the subscriber profiles are stored there, right? PCRF is the policy control function for quality of service, right? So different nodes present in the 4G era like a physical entity. Each node, these nodes are different nodes and their hardware and their softwares are differently installed in different location of the 4G core network, right? So these are physical node entities in the legacy network, but in 5G, all these are converted into network functions. Different functions are there. PCF, last, all these things, na? F stands for function. AMS, SMS, AUSF, SMSF. So different functions are introduced, and all these functions are virtualized. It is a virtual network function. It is not a physical network function like in 4G. That virtuality comes in the form of server in a single node. In the single server, there are number of virtual machines on that virtual machines. The different virtual network functions are installed on the top of that and they are working independently. Logically, they are working independently, but physically there are single nodes, right? So all these 5G core network control functions are virtualized. Because of this virtualization, we can shift the core network into the cloud also. That's why the cloud, edge cloud, the cloud native functions of 5G network is possible because of this virtualization. Clear, sir? In the 5G, only one node present in the for user plane function. For user plane function, only one node present in the radio access network and only one node present in the core network. That is the UPF. All these cores, the CP means control plane, right? UP means user plane. In the user plane, only one node is present in the core network. Why only one node? To reduce the overall latency. One node present in the radio access network and only one node present in the core network. That is known as the UPF. That is not written here, user plane function. Clear, sir? Any question in this slide? Service-based architecture. All the physical nodes converted into virtual nodes. Virtual function, you can say. So what are the advantage of converting physical node to virtual node or virtual function? Their scaling up or scaling down may be possible very easily. Flexibility, there is a lot of flexibility it provides. Virtualization provides the flexibility. In the virtualization concept, you can imagine, if you imagine a smartphone. Previously, before 10 years, we are having the keypad phone. All these keypad actually physical keypad. But now in your smartphone, keypad is a virtualized. It's virtualized, keypad. Now what are the advantages you have from if you compare from the previous generation 2G or 3G handset where the keyboards are physical. Na? One advantage is their size of the keypad may be changed in the virtualized smartphone. Keypad is virtualized in the smartphone. So you can change the size of the keypad. You can change the language of the keypad. You can remove the keypad whenever you want to see any movie or anything. Right? When you want to use keypad, they are appeared after you are not using keypad, it will disappear. So these are the flexibility comes because of virtualization. Right, sir? Similar types of things appears here in the 5G core network and radio accession. All these nodes are virtualized basically on the single top of cell. These are the different actually the nodes physical form, and here is the virtualized network functions. There are different functions. Actually, the functions of different nodes are same, whereas the physical existence is changed only, but their functions are same. So there is a comparison written here. What is the function of MME in 4G? That is the mobility management, authentication management, and packet data network session management. All these are handled by MME. But in 5G, the different specific module is for one function. That means mobility management handled only by the AMS, and authentication management handled by the AUSF, authentication security function, right? And PDN session management handled by the SMS. Previously, it handled by the MME as well as PDN gate, right? And serving gateway in 4G handled by the same function is handled by the UPF in 5G, and PCRF policy related handling capacity things handled by the PCRF in 4G, where in 5G that is handled by the PCF policy control function. And HSS, that is the subscriber database. In 4G, that is the HSS, but in 5G, it is a UDM, Unified Data Management. UDM means Unified Data Management. These are the just comparison of 4G and 5G core network. Different functions are there. Functions is the same, but nodes are different, right? Node here is the physical node, but here is the virtualized network function. But their work and their functions are the same, right? First, here is the changes has been done in the 5G network. That is the CUPS. CUPS means control and user plane separation. In the 4G, somehow some traffic is separated, but not fully separated. The traffic of 4G, core net or control plane and user plane. But 5G control plane and user planes are totally separated. In 5G, in our legacy network, you can see here in the left hand side, right? All the you can see rather this slide, this slide. All the traffic goes from their user equipment and comes via the core network only. The voice traffic comes from user equipment and goes here core network and comes from that frequency. But in 5G, this is not the case. All traffic goes from user equipment to mobile base station and then go to core network and comes from that here only. So it takes a lot of distance. Because of this traveling, transmission delay is there, and latency is high in legacy network. But in 5G, your core network are distributed, you can say. Some of application there is a flexibility. So for some of application, that server comes near to the user. That's why here is written here, app server. That is known as the edge data center. Some of the application, it is located at the local data center, or you can say regional data center, or you can say regional cloud. Okay, There is a central data center, that is the part of centralized location. Okay, central cloud you can say. For different applications, depending on the user experience or application requirement. If there is a requirement of very low latency, that means your server is to be installed here near to the user. That means near to the base station, right? So depending on the scenario, you can change the location of the core network. Change the location of the core network. Rather, not only application. There are application server that is beyond the core network that is also shifted towards the user. By changing this, latency can be drastically reduced. Latency can be reduced or not? Reduced, na? There is a reduction in the transmission delay, right? If we can take an example of our online shopping, na, in the previously, na, before earlier times, all the server, na, control server or centralized location. Suppose we are here in the anywhere, suppose Varanasi or Lucknow, any city. If you order something, suppose a central server of Amazon is sitting in the Bangalore, right? We make a order. Suppose we make a order of something, some goods. We make a order and make a payment. After making the payment, order confirmation is done. These are the control tactics. After confirmation the order, your goods will be dispatched. Na? In the earlier times, it will take more than 1 week. Why? Because your control plane and user planes are centralized at a far away location, right? But nowadays, the delivery time is reduced. Why reduced? Because your user plane, your control planes are centralized still, but your user plane comes near to the user. Like Geo, na? Geo, they are collaborating with the shopkeepers of local shopkeepers. That's why they are delivering the goods within an hour or within a 30 minutes. They guaranteed the delivery of 30-minute delivery. Why? Because user planes are shifted near to the user. That is the main point of reducing the delay or latency. Clear, sir? That similar types of things are coming in the 5G network. Your user plane are shifted towards the user. Clear, sir? Any question? No question.
No question.
Okay. The MEC, the similar thing, mobile edge computing. That is the name of mobile edge computing. The specification given by MEC of ITSI, European Standards Institute, right? The MEC, main purpose of MEC is to reduce the latency. All the applications, your data server comes near to the user to reduce the latency. That is the name, actually specific name is given for this. That is the MEC. The full form of MEC is the mobile edge computing. All the computation, server application, core network comes near to the user. Right? Here is written previously the centralized resource deployment is there, but now because of MEC, the distributed resource deployment flows to the terminal. The lot of application of MEC is there where very low latency required actually, like driverless car or vehicle to vehicle communication, right? Where latency is required very less, or you can say robotic surgery or in-house campus of any university. If you want to secure your data, if you don't want to move your files from your location to in the public network, then you can install this types of 5G network and see there. All these your storage and your everything is within your campus, right? These are the different applications, that is the specified 7 MEC applications defined by HC, right? These slides are taken by the Huawei website. The enterprise traffic steering, video optimization, AR, augmented reality, Internet of Vehicles, Internet of Things, right? Assistance for intensive computation. So there are lot of benefit of using this MEC, mobile edge computing, or we can say edge cloud, right? What are those benefits? First is the reduce the latency, and second benefit is the security point of view. Your data is not going to the public now. Now your all data storage, everything are near to the user or within the campus, you can see. That's why that is more secure. MEC makes your all the data more secure. And one more benefit is to reduce the bandwidth. Actually, your data is now not going towards the aggregation layer and core layer, right? Your data is just moved from base station to your MEC. Now your bandwidth is saving actually. Bandwidth is saving between the in different layers, aggregation layer and core layer and access layer to aggregation layer, right? So there are three main benefits, right? The first is the latency, second one is the reduce the bandwidth, or you can say save the bandwidth, not reduce the bandwidth, because save the bandwidth, and third one is the it can be more secure. Now after this, all these are the we are talking now regarding core network architecture. Now the radio access network. What are the changes done in the radio access network of 5G, right? Previously, all of you have might be seen antenna is there on the top of tower. That and below the antenna there is a remote radio unit. RRH, RRA. There are different names actually. Sometimes it is a RRU, remote radio unit. Sometimes remote radio head, written RRH, right? And this RRH is connected with the antenna, right? And this radio unit is connected with the BBU, baseband unit. Baseband unit connected with this RRU via fiber cable. That fiber cable runs on the protocol of CPRI and enhanced CPRI. CPRI is used in the 4G, but now that is enhanced, means that bandwidth is enhanced, that is the enhanced CPRI. These are the separated in the 4G, right? But 5G, many of the vendors, Samsung, Nokia, Ericsson, all of these are providing the Huawei, all of them, these are providing the AUU. AUU means Advanced Antenna Unit. That means all your antenna unit, right, and RRU are combined in the single chamber. You have to have only one antenna, big antenna or heavy antenna installed at the base station that is connected with the your BBU. That BBU may be in the cloud, maybe in the edge cloud, maybe in the central cloud. Okay, it depends. It depends on the application, right? That means only one now the AUU to be installed at the tower. Because of this, you can install this unit to any pole. Any pole means any you are using traffic light poles or different poles of municipal corporation. You can install just because of just of one unit. You can just put one unit on that pole, and you have to just give a one power and one cable of this CPRI cable. Two things are required to connect it with the BBU. Right. Further, we split the BBU in two parts, that is the distributed unit and central unit, right? Centralized and decentralized, you can see. Some of the core part is the centralized, that is goes into the cloud, and distributed parts are distributed, right? These are the some changes has been done in the 5G radio access. Any question in this slide? No question, sir?
Get the what major difference you are talking about here, or the key difference?
Major difference means one thing is that your antenna, actually antenna becomes the advanced unit. Advanced antenna unit, that is the radio unit combined with the antenna. Now it becomes smart, right? That is the active antenna unit, rather you can say, and this is connected with the your decentralized unit or distributed unit and central unit. Sometimes it will
And RRU are same, merged in one block.
RRU is the same, but built within a single unit, single antenna type of unit. That is known as the advanced antenna unit.
And rest are the same. Is there a more difference than apart from these two blocks?
Apart from these things, a number of antenna, multiple antenna are used in the 5G. That is known as the massive MIMO. Antenna is changed, na?
Yes, that is.
Massive MIMO antenna is used in the 5G base station. That is the massive MIMO means your large number of antenna is used. This thing actually beyond 8 cross 8, 3GPP is specified as a massive MIMO. That means 16 cross 16 and 32 cross 32 and 64 cross 64 MIMO is termed as massive MIMO.
Okay.
Right, sir?
Okay.
All of you understand regarding MIMO or not?
Yes.
Okay. These are the same thing I have discussed here, na? Advanced antenna using connected with the BVU. Sometimes it is maybe at the base station, maybe at the remote location, depending on the use case. So now front haul requirement is very high, na? 5G having how many? Here is the right hand side, na? Bandwidth is written here. 20 megahertz bandwidth is used in the 4G and 100 megahertz and 400 megahertz is used in the 5G. The carrier bandwidth that we are using, na? 4G, that is the 20 megahertz maximum. All of you know or not? What are the carrier bandwidth used in the 4G network? Minimum is 1.4 megahertz. Any operator can deploy their service of LTE minimum with the 1.4 megahertz and maximum it is 20 megahertz. Right? Right, sir? In LTE. But in 5G, there are actually bandwidth is flexible. Sub 6 gigahertz band and millimeter wave band spectrum, where the capacity is very high. In sub 6 gigahertz band, a maximum 100 megahertz bandwidth can be given to the 5G. And your antenna configuration is increased from 4 cross 4 in LTE to 64. You can see here 16 times increase in the number of antenna, or you can say number of transmission and reception. That will increase the overall capacity of the network. That requires a higher bandwidth front haul. Front haul means connectivity between advanced antenna unit to BBU. Right? If you want to increase the capacity, there is a requirement to enhance the C3 bandwidth. That is the enhanced C3. Clear, sir?
Yes, sir.
These are just a comparison of 4G bandwidth and 4G MIMO. Not you can say 4G, but it is a LTE comparison. 4G is a LTE advanced actually, right? Where we can make a 20 megahertz bandwidth to make a 100 megahertz carrier bandwidth by using the carrier aggregation technique. This is a simple 20 megahertz of LTE and 4 cross 4 MIMO that is used in the LTE. Now that is increased 5 times increase in the bandwidth in the sub 6 gigahertz band and 16 times increase in the antenna, number of antenna, so that the capacity can be improved up to one base station. What are the capacity? Peak data rate is the 20 gigabits per second in the 5G in downlink guys, right? And 10 gigabits per second in the uplink guys. Now these are the protocols where they are split in the centralized unit and distributed unit, and lower 5 layer goes into the radio unit, right sir? The RRC layer and PDCP layer, main control layer, are higher layer. Layer 3 functions are contained in the centralized unit, and RRC layer and MAC layer are comes in the distributed unit, and lower 5 layer physical layer comes in the radio unit, right? That is written here. The most popular breakdown between the different units, that is this one option 2, that is also subscribed by 3GPP, right? That is the most popular. This slide I think already discussed. Now one thing is the feature of 5G network, that is the network slicing. What is the network slicing? If you compare our previous generation legacy network LTE and 4G, what are the parameters that is handled regarding the quality of service? That is the reason. Only quality of service is there. That means quality of service means priority of something. Some channels having priority, sometimes some users having some priority, right? The different priority are given for different users, different plan, different right, different use cases. Only one thing is there, that is the quality of service in our legacy network. But 5G having more, you can say reliable, or you can say user performance is improved because of both quality of service as well as network slicing that is introduced in the 5G network. So what are the difference between only quality of service and quality of service plus network slicing? This slide clears the picture. This slide is also from the Huawei, right? The slide I have taken. You can see here, here all the applications. There are different applications, mobile broadband and some low latency application, massive connections. All these applications are share the resources of the 4G network. Sharing the resources of 4G network is not a good thing for in terms of reliability, right? If you can take an example of your vehicle, like ambulance on the highway. Suppose 4 lanes, 5 lanes or highway is there, and some accident may be happen. Suppose might be happen, one accident is there. So all the users, whether they have a transport vehicles, public vehicles, or right, or on private cars or ambulance, all types of applications or vehicles are sharing the same highway. Sharing the same highway because of an accident, their ambulance are given the priority, but after giving the priority, they may not cross that traffic or that congestion of the road because of all these applications. All these are vehicles are sharing the road, right? But here in 5G, all the applications are not sharing. All the applications giving the dedicated resource, logically dedicated resource, not physically. Logically giving the dedicated resource so that the performance of the service may be improved. How the resource are dedicatedly, logically divided, just like your PC. If you compare a hard disk, 1 TB hard disk, suppose you have a 1 TB hard disk, and you divide in logical drive, C, D, E drive. All these memories or resources are logically divided. C drive is memory is logically divided, D is divided. Okay, they are not dependent on each other. Similar types of, but there are one single physical hard drive, similar types of one physical network is there, 5G network. On the top of one physical network, you can implement a number of logical networks. That is the network slicing. Number of logical networks for different applications. 5G supports a large number of applications, not only for the mobile broadband, right? A large number of applications are there in 5G because of higher throughput and very low latency. Very low latency is very important in 5G. That enables a number of applications. That latency is the 1 millisecond latency. Clear, sir?
Yes, sir.
Okay. Now we will discuss some key air interface 5G technology after the architecture. Up to this slide, I have discussed the architecture of 5G and the base station radio access networks and core network and these network slicing feature of 5G. Right. The new air interface technology comes here. You can see here the high bandwidth, new coding scheme, high order modulation, filtered OFDM is used, massive MIMO is used. All this by using this all three technology, na? High bandwidth, new coding scheme, higher order modulation, filter OFDM, massive MIMO. All this will enable the rate increase or increase in the capacity. How you can increase the 20 gigabits per second peak data rate, user data rate by increasing these things, 5 things. That is main 5 things. All of you know high bandwidth means we are using the up to 400 megahertz bandwidth in the 5G in the millimeter wave spectrum. Right, sir? This is the one of the case by using which you can increase the capacity. A new coding scheme are used. What is the coding scheme? Coding scheme basically to add the redundancy in the user plane traffic, right? For recovering the data at the receiver side. If you reduce the redundancy means you are increasing your throughput, user throughput. Overall performance is increased because of adding new coding scheme, or you can say more efficient coding scheme used in the 5G network. And third one is the higher order modulation. Higher order modulation means what are the higher order modulation used in our 4G network? Can anyone please tell me? What are the modulation techniques used, digital modulation techniques used in the 4th generation network? Jitin sir?
Sure. I am not from core communication. I am from DSP, sir. So that I might be not able to exactly guess, but although I have studied in my BTech, but not touch with.
Okay, no issue, sir. Actually, in 3G, in 3G, QPSK are using. In downlink and uplink is the DPSK, right? QPSK, it is just actually a symbol is coded with 2 bits. A symbol is coded with 2 bits of information, user information, right? In DPSK, a symbol is coded with only 1 bit of information.
Yes.
If you are using higher order modulation, 2 bit, 4 bit, 8 bit, 6 bit, that means we are increasing the data rate by using the higher order modulation. That will increase the spectral efficiency. But these modulation means DPSK, QPSK, after in 3G, HSDPS 16 QAM, 64 QAM. These are the different modulation techniques used in the LT, right? But in 5G, the after 64 QAM, that is the 256 QAM add. That means 8 bits are mapped onto one symbol. Our symbol time is fixed, but number of bits that we are mapping on the one symbol, that is increased by using the higher order modulation. By using this higher order modulation, we can increase the capacity or we can increase the rate that we are achieving in the downlink direction or uplink direction. Right, sir?
Okay. So what are the beats in 3G, 4G, and 5G?
What are the
beats we are using now in modulation higher numbers, sir? In 5G, how many bits?
bits? Bits means, sir, 64 comm means how many bits? 2 के power.
Oh, that in 3G and 4G.
In 3G only QPSK we are using, but in a further enhancement in the 3G 3GPP releases we are using 16 QAM. In 3GPP release 5. After that in 3GPP 7 we are using the 64 QAM in 3G network itself. Right, sir?
Okay.
But in 5G we are using 256 QAM.
Okay.
In the future specification release 17, it may be 1024 QAM. Right?
Yes.
But one disadvantage there, we are not increasing that so much higher order modulation because it requires the higher SNR value. The coverage of that higher order modulation is not much higher.
Yes.
It is near to the user only, near to the base station. Right, sir?
Okay.
Next one is the filtered OFDM. Filtered OFDM means OFDM is same SS method or multiplexing techniques. Same is used in 4G and 5G. But here F is used, filtered is used because to increase the, what is increased in filtered? Filtered means your bandwidth, suppose carrier bandwidth is 20 megahertz. Suppose that, right, sir?
Okay.
20 megahertz. So within 20 megahertz, some guard band is there on the both side of bandwidth of both side of the carrier. Usable carrier bandwidth is only 90%, or you can say 18 megahertz in the LTE. Right? The transmission bandwidth of the carrier bandwidth is 90% in case of 4G. But by using this filtered technique, we increase the transmission bandwidth of the carrier. That is up to 98 or up to 99%. From 90 to 98%. The spectral, the bandwidth efficiency we can increase. Because of this bandwidth, if we increase the efficiency of the bandwidth, we can increase the capacity of our network. Right, sir?
Sir, what is the reason behind that we are using this guard band for the particular channel? Means 10% loss due to the guard band is why it is required for the particular cases. We can go for the perfect sampling cases also, no? FM is equal to 2.
Because precise filter is not available in your handset and your base station. Actually, adjacent carrier are given to different operators, right, sir? Different 5 megahertz or 20 megahertz carrier, adjacent carrier are given to different operators. Okay, a precise or advanced filter are not used in your mobile handset and your base stations. Okay, you cannot use because of, if you use very precise filter, that means it will increase the cost of your handset. That is not a favorable case in terms of user. That will also see by the ITU and 3GPP. The more popular technology, that will become cheaper rate. That right, sir? One of the reason is the cost, and another reason is the interference. Two reason is for their for giving the guard band between the carrier. Right, sir?
Okay, sir.
Okay. Next is the massive MIMO. I have already discussed massive MIMO. If you increase the number of carriers, I will see one application. I think these are this one. Add this one equation, Shannon formula. Capacity is equal to B log to 1 plus SNR. Right, sir? So capacity of any network is proportional to bandwidth. This equation holds only for one wireless channel. If you are using MIMO, MIMO means we are increasing more number of channels. That means this equation change from this B to, if you multiply B into M, C equal to B into M log 2 plus 1 plus SNR. That means if we increase the number of antenna, that means we increase the number of channels. If we increase the number of channels, it will increase the capacity of the unit. Right? This Shannon theorem C equal to B log 2 1 plus SNR, it holds only for the single wireless channel. But in 5G or 4G, we can increase the number of channels by using multi-input and multiple input and multiple output MIMO. We can use higher order MIMO to increase the capacity of them. But still MIMO requires the interference-free environment. In the highly interference environment, we cannot use higher order MIMO. Right? There are a lot of techniques to remove these challenges of massive MIMO in the 5G network. Multi-user MIMO, single-user MIMO, that is used to enhance the capacity of the mobile network. Right, sir? We are having on this slide. These are the different technology by using which we can increase the throughput of users, or we can say increase the capacity of the network. Here in the right hand side, how to reduce the latency. Here some of the regions are air interface region is written here, and architectural region I have already discussed how to reduce the latency. Can anyone tell me what I have told previously? What are the architectural situation where to reduce the latency? By using architectural changes, we can reduce the latency. What are those changes has been done in the 5G network?
At the local level, we are expecting layer multiple.
One reason, very good, sir. One reason is the MEC we are using. We are shifting our all the applications that core network are near to the user.
Yes.
Right. That is the first architectural changes. Because of this, we can drastically reduce the latency. Second reason.
Slicing, I think so.
Slicing is the reliability issue, that by which we can make more user performance. We can increase the reliability of the application.
Okay.
And the number of nodes. One thing I have written, number of nodes, number of hierarchy we can reduce in the user plane of 5G network. Right, sir? Number of hierarchy views, because of in the radio access network, we are using only one node, that is the G node. And in the core network, user plane, we are using only one network function, that is the UPF. That means hierarchy is reduced. That's why the processing delay can be reduced by reducing the nodes. Because of this processing delay, we can reduce the overall latency of them. Right, sir?
Okay.
Another these four techniques are used at the air interface to reduce the latency. That means first one is the flexible frame structure. I will discuss in subsequent slide what is the flexible frame structure, right? Next one is the self-contained slot, grant free scheduling, and device-to-device communication. These are the four techniques by using which we can reduce the latency, air interface latency. Right? By using this, we can reduce only the air interface latency. Right, sir? For coverage improvement, some of thing is written here: uplink and downlink, decoupling. Right? Massive MIMO. How massive MIMO can increase the coverage? Because of if you are adding more and more antenna, that antenna may become a beam forming antenna. Beam forming means there are coverage in the desired direction. Particular beam width is very small, maybe 9 degrees, maybe 7.5 degrees. That means they are lesser interfere to other side direction radiation. That means SNR can be improved. If SNR improved by using beam forming, the rate or the capacity can be improved. Right now, if SNR is very poor, comparable to zero, what it means? If you are not getting anything, whether there is a large bandwidth, large number of MIMO, but SNR is poor, that means you are getting throughput is zero. So SNR is a very requirement level, or you can say parameter by which you can optimize your network, right? Now the bandwidth, here is the bandwidth. What are the main bands that is used in the 5G network? Just a brief discussion. Two frequency bands are there, FR1 and FR2. FR1 means frequency range 1 and FR2 means frequency range 2. So frequency range 1 is also known as the sub-6 GHz band, right? In the 3GPP release 15, it is a sub-6 GHz band. After release 15, release 16, some of the 1.1, 0.25 GHz bands are added. That becomes the 410 MHz to 7.1 GHz. Okay. And FR2 is a millimeter wave spectrum. Millimeter wave spectrum that is used for the capacity purpose. The maximum carrier bandwidth that is used in the FR2 band is the 400 MHz, right? And maximum bandwidth, carrier bandwidth that we use in the FR1 band, that is the 100 MHz, right, sir? You can see here now two bands, 5G primary band and 5G extended band in the millimeter wave band for capacity purpose, right? So there are two bands. Up to 4G, we are using still less than 3 GHz band, right? Up to 4G, we are using still up to less than sub 3 GHz band, we can say. Sub 3 GHz band is used in the our legacy network, right, sir? And from 3 to 6, or whether you can say C band of 5G network is added in the 5G network. This C band and this millimeter wave band are additional band that is added in the 5G network. This point is clear, sir? What are the additional bands added in the 5G network? This one from 3 to 6 GHz band. This band is also known as the C band, right? And this millimeter wave band that is added in the 5G network. And this two bands, C band and millimeter wave band, runs on the only the TDD mode. All of you know the sir, TDD mode, transmission mode, and FDD transmission mode. FDD transmission mode means frequency division duplex mode, and TDD means time division duplex mode. In the FDD, the uplink and downlink. All of you know, I think, uplink and downlink. Uplink means when your mobile transmit on any frequency, that is the uplink. When your mobile receive anything on your mobile, that is the downlink. Receive from base station, that is the downlink. Transmission is uplink from mobile side and reception is the downlink. When both transmission and reception has been done on the different frequency, that is known as the FDD, right? And when transmission of uplink and downlink are done on the time basis or orthogonal time slot, that is known as the TDD transmission mode. That means C band and additional millimeter spectrum band are based on the TDD, that is specified by 3GPP actually. Or your handset, everything are equipments are manufactured on this TDD mode. But less than 3 GHz supports all these bands, FDD, TDD, and some supplementary SUL and SDL, some supplementary additional reflecting modes are there to enhance the coverage of these. This slide is clear, sir?
Yes, sir.
These three bands are written here: sub 3 GHz band and C band millimeter wave band. Sub 3 GHz band, spectrum band is used by legacy network, right, sir? That is used for good coverage. Lower band is always good for coverage, and higher band is used for capacity purpose. The lower band is also known as the coverage band, and higher band is also known as the capacity band. The C band and millimeter wave band are additional band that is added in the 5G that works on the TDD mode. That was C-band and millimeter wave band works on the TDD mode. Okay, sir. These are the some I have already discussed higher order modulation. By using this higher order modulation, when we can increase the network capacity, and by using wider bandwidth, wider carrier bandwidth, we can increase the capacity of the network. 400 megahertz, 100 megahertz. In C band, maximum is the 100 megahertz. In millimeter wave band, maximum is the 400 megahertz. Same thing is written here, FR2 maximum 400 and FR1 maximum 100 and minimum 5 megahertz. Whereas in an LT, if you compare from LT, minimum is 1.4 megahertz and maximum is the 20 megahertz. These are the protocol steps, right? RRC, PDCC, RLC, MAC, and 5 layers, right? One additional layer that is added in the user plane, that is the SGAP. All other are similar to 4G networks, right? SGAP layers is added in the 5G network. Okay, sir. These are the physical layer processing, how the physical layers are processed, right? Rate matching, interlink, code block concatenation, sampling, modulation. Okay, all these are the similar to our 4G network, but their coding and their modulation and their resource matching, number of antenna, number of RF streams, they are changing. Otherwise, the cascading block is just similar to our 4G. Okay, now comes on the channel coding. The channel coding, why channel coding we are using in all the generation, second generation, third generation, fourth generation? Because of the reliability of the data rate. We are receiving, suppose SNR is poor, very poor, we are adding some redundancy to recover the bit error rate on the receiving side or the receiver side, right? If we reduce this redundancy, means we are increasing the capacity of our network. By using the LDPC and polar code, by using LDPC and polar code, we are increasing the what are we are increasing? We are reducing the redundancy and we are increasing the information distance. By using this, we can increase the throughput of our network. Okay, so LDPC and polar codes that we are using in the 5G network, and turbo code and convolution code that we are using our legacy network, 3G and 4G network. Okay. In detail, if you want to go into detail of what are the algorithm, what are the things by which we are generating this redundancy, that are the different. All these are coding techniques, means we are generating the redundancy to improve the performance of the code. Right, sir? We are speaking this that the polar code is more efficient. These are the different higher order modulation technique. By using we can increase the capacity of the network. The higher order modulation, this picture is very important actually. You can see here the higher order modulation requires the higher SNR to decode, right, at the receiver side. That's why the 256 QAM or 1024 QAM is very near to the base station. And if you go beyond the cell, beyond the BTS, your base station is scheduled lower order modulation, so that your mobile handset experience the lower throughput if you are beyond the cell. Rather, we can say lower order modulation is more robust in the interference or at the cell level, cell edge, and higher order modulation is not robust in the interfering. It requires the higher SNR. Because both phase and amplitude are very less between two constellation lines. You can see here in this left hand side. filtered OFDM, I have already told you that is the 10% guard band we are using in the 4G network. Now this guard band is reduced, right? Only 2 to 3% guard band used in the 5G. Means 98% efficiency we are using in the transmission line. One flexible frame structure I have previously told you, na? In the 4G network, the radio frame is the having of 10 milliseconds. The 10 millisecond frame structure is same in the 5G network. And frame is further subdivided into subframe. Right, sir? That is subframe duration is 1 millisecond. And this subframe is further divided into the slots. The radio frame and subframe is the same. This duration is the same as 4G network. But slots and symbols are flexible in the 5G network. That's why we are saying the flexible frame structure in the 5G network. Right? In 4G, the frame structure is fixed, but 5G having the flexible frame structure because of there are different applications. Some applications require the lower subcarrier spacing. Some applications require the higher subcarrier spacing. All of you know, sir, subcarrier. What is a subcarrier in OFDM? Subcarrier means our one carrier, suppose in the 5 megahertz. In BSNL, we are using 5 megahertz in the T network, right? In the 3G network, the single carrier transmission is there. Our data is transmitted on the single carrier. But in 4G and 5G, our user information are transmitted on the parallel subcarrier, not serially transmitted on a single carrier. One carrier component further divided into subcarrier. That is the concept of OFDM. The subcarrier spacing is fixed in the LT, that is the 15 kilohertz. But in 5G, it is a flexible. Because of this flexibility, 15 kilohertz and 30 kilohertz, 120, 60 kilohertz, 120 kilohertz, and 240 kilohertz. We are increasing and decreasing number of slots and number of symbols in their subframe. Right, sir? This is the basic modulation. On this symbol, we are mapping our different modulation technique. 64 form, right? 256 form, 16 form, QPSK. So on this symbol, basically symbol time is fixed. On this wireless symbol time, we are mapping more and more number of symbol bits. That's why we are increasing the throughput by using higher order unit. Basic modulation unit is the symbol on which we are mapping the user information. Right, similar architecture is written here, fixed architecture in the LT, and that is the SCS subcarrier spacing. SCS means subcarrier spacing based flexible architecture, that in the 5G. Same flexible frame structure is written here for different subcarriers. Right, sir? For the case of 15 kilohertz, you can see here in the 5G. TTI means scheduling time actually. The TTI is done on the slot basis in the 5G network, where is the in the 4G network, the scheduling is done on the basis of subframe basis. Right. So one slot means in the 5G, one TTI. One TTI means how many symbols? 14 symbols. So if you are increasing the number of slots, your TTI reduced or your slot is reduced, right? Your number of symbol capacity, handling capacity symbols within a frame is increased. If you are increasing the subcarrier spacing, that means you are increasing the number of slots. The 2 slots available in the 30 kilohertz subcarrier and 60 kilohertz subcarrier, you are having 4 time slot in one subframe. Right, sir? And our slot format, there are different flexible slot format is given for 5G. the slot format is fixed in the 4G network, but 5G that is flexible. Type 1 is the downlink slot only, type 2 is the uplink slot only, and type 3 is the flexible slot only. Okay, and type 4 is the at least one uplink and downlink symbols, other symbols flexibly configured. X means type 3 X means that is the flexibility. It may be downlink, it may be uplink. That type of flexibility is not there in the 4G network. The flex content slot means in the acknowledgement or your data transmission time is done in the same slot, wherein this is not specified or standards given in the 4G network. Within the same slot, your downlink scheduling and data transmission and harsh feedback are done acknowledgement or not negative acknowledgement done on the same time slot. Why? To reduce the latency, not for all the application actually. All these things are the flexible depending on the application. The self-contained slot is used only for lower latency, or we can reduce the round trip time delay for uplink and downlink data. Clear, sir? Now I am grant-free scheduling. That will also reduce the air interface latency or signaling latency at the air interface, right? In the 4G, you can request and then G node be grant and then UE transmit something. But grant within a grant-free scheduling, these two states, request and grant state is removed, and you can direct transmit the URLLC data. Where the URLLC code is written here, that means your data is URLC. You are no need to send first request and then achieve grant and then transmit the user. Okay, so grant-free scheduling is also used for reduce the latency in the network. Right, massive MIMO, I have already discussed 64 to 3GPP release 16, the 64 cross 64 already implemented by many vendors, right? 64 cross 64, 16 cross 16, 32 cross 32. That all these things are increase the capacity and also increase the coverage, because the more number of antenna can make a huge coverage because of beam fault. It makes a beam, more antenna makes a beam, and this makes beam increase the coverage of them. Right, sir. Thank you to all for listening me. And if you have any questions, sir, please ask me.
Very good lecture, sir. For all the queries that we got.
Any questions, sir? No questions? I have given just an overview of all these things, 5G architecture and some brief technology by which we can increase the capacity as we can reduce the latency of the 5G network. Any questions, sir? If you want to, then whether you can submit the question in the chat box. There is a loudspeaker. Actually, speaker is there. Where is the voice quality is not so much good. Jason, sir, you want to ask anything? So I think we should stop here, and thank you to all, sir.
Thank you, sir.
Okay, thank you.
Thank you, sir.
These are things.